So whenever you guys are good.
It looks like you're still driving.
No, just in the passenger seat right now.
Oh, okay. All right. Well, go ahead. I've got the list in front of me.
Okay. So, Greg, well, what is it? Where do you work at? What do you do specifically?
So I work at Fisher Industries. My job title is civil engineer.
Okay, cool. And how long have you been doing that?
Well, I've been an engineer at Fisher for 10 years. I've been a registered engineer since 1985.
Okay, cool.
And I've been working in the construction field since I was 18. So that's 47 years.
Wow. Okay, cool.
Way before us, right?
Yep. Yeah. Back in the good old days.
Right. So now that we know a little bit about you and what you kind of do, we'd like to know how you incorporate technology into your daily work or into what you do, and what technologies you use specifically, if we can go into depth.
Okay. Are you? Oh, you're already. Okay.
We're looking at 5 right now.
Yeah, no, I was just looking at the other ones. So are you assigned to a project or job site? Okay.
Oh, yeah, actually, let's jump back there. Sorry, we might have messed over one. So yeah, are you assigned to a project? Do you work in the office? I mean, I know, I just want to get everybody caught up.
Yeah, so we have quite a few different projects running. Usually any project that has structure work or hydrology or value engineering or constructability issues, I'll wind up getting involved in it. So I don't run a specific project by myself. We have project managers for that. But then when they need an engineer, and there's only a few engineers in Fisher out of our 1,600 people, then I take care of it. So we're building, for instance, we're building a big bridge interchange job in Kingman. We're building a resort over by Cardinal Stadium. We're building a couple of big freeway projects in California outside of Blythe. And sometimes it's little stuff. There's a bridge at Salome Interchange where we're cutting off the edges of the bridge and putting on a newer type of safety barrier. So I have to design the fall protection system for that because it's part of the, it's work on a structure.
Gotcha.
Yeah.
So wherever you're needed, you kind of go and do the engineering for that. Nice plug and play job. I like it.
Yeah. Mm-hmm.
Yeah. So that's awesome. So yeah, going, I guess, with that and how you're going to each project, trying to kind of problem solving, whatever the problem is that day.
Mm-hmm.
How do you incorporate technologies while doing that? And what are 2 technologies you may use?
Well, we do purchase some software licenses. There's a lot more expensive ones and probably a lot more powerful ones that we don't use every day because we're not really a design consultant. It's just basically solving problems at the contractor's level and a little bit more real world. But
right,
we use some survey software. We use some field location software, property ownership software for when we're looking at pits and stuff like that. So I basically am the engineer for our construction materials testing lab.
Gotcha.
So we'll do pit applications with the state mine inspector and stuff like that. But yeah, I can't even log onto my computer without having my phone in my hand. So there's technology everywhere.
Gotcha. So For the first one, I have picked technology, and you kind of explained what they're used for,
Mm-hmm.
kind of problem solving,
Mm-hmm.
getting information, and I mean, you elaborate on that a little bit. I kind of want to go more into depth on the technology aspect. And the reason why is this interview is for a technology class, so we're kind of
Mm-hmm.
seeing how industry professionals incorporate that. So if you
Yeah.
can, maybe say the application, or I don't know, however
Okay.
you want to go
So
about that.
I mentioned sometimes we have hydrology problems, and so we'll use a program called HEC-RAS. It's developed by the Corps of Engineers, been around for quite a while. We do, uh, um, just basic flood analysis with it. We used an early version of it 25 years ago when I was the city engineer for City of Holbrook, and we had to reset the floodplain after they had constructed a new levee through town.
Hmm.
It's lots of different things that are involved.
And kind of going with, I know you used the application 25 years ago, and I mean, I would assume you may still use it to this day. I
Yep.
guess over the time, what are some of the things that you like about the application, and maybe some dislikes that could be improved on it?
Oh well, it's definitely been upgraded and gotten better. I think it's on version 22 now. Um, but I don't know. I like the fact that it doesn't cost $40,000 to get a 1 year license. That's that's
Oh,
part of the headache. Like SolidWorks is one that we're sort of playing around with, but that license is $45,000 a year.
Jeez.
Yeah, so it doesn't really pay a contractor. If you're a consultant and you're doing that work every day, or we have a branch of the company called General Steel up in North Dakota, and I believe they have 5 of those licenses, and they renew them every year. But they're designing mechanical parts um, for all kinds of stuff that we build. We've got some models in our office of some of the products that we build as far as conveyors and air separators and crushers, things like that. So yeah, if you're designing that every day, then it helps to have something so you're not sitting there drafting like in the old style with a pencil and eraser and a square. Uh, but that's a big step forward. So yeah, we've got all kinds of software throughout the company, but you have to be um, pretty well versed in it and focused on it. Uh, you know, you can't just sit down and start using it one day. It's and you guys get a lot of education in your classes on many of these, I'm sure. So
Yo, that's what
yeah.
this class was made for, actually,
yeah, okay.
technology itself. So, and I mean, you kind of answered 10 through 13 while mentioning SolidWorks, honestly.
Mm-hmm.
So
Mm-hmm.
that hit the money on that. So I'll let Dusty take over this wild card question and kind of get some more input, and then we can call it after that.
Okay.
Oh, okay. So, what is a piece of advice for students that you could give that are preparing to use like these technologies in their future careers?
Um, I think it really helps to get out and see what the industry does. If it's shadow days or um, career fair, like Xavier is doing, coming to work for a company and understanding some of the things that um, function and what speed they function at versus, we're a construction company. We can't afford to research stuff for months and months and months on end. Although sometimes it gets into that mode, it seems like. But at
Yeah.
some point, you have to stop the clock on the design and say, here's what we're going to build, and here's how we're going to build it, and then you've got a budget. And so, um, my dad used to tell me, he says, "Well, an engineer can do for $1 what any damn fool can do for $10." It's all about efficiency. It's all about value
Yeah.
engineering. Um, And if the program is usable enough and you're familiar enough with it, like with HEC-RAS for flood control, then you can use that to get an answer that 20 years ago you couldn't find a computer that could even run that. And spit out the output and give you that kind of detail. And part of the reason is they didn't have that level of data either. So now we've got terrain that's scanned by LiDAR. So you can make a model of what the watershed basin is going to look like. It's got all the slopes, it's got all the soil types, it's got all the elevations and the areas. And HEC-RAS has advanced enough now to match with that. And it can tell you, you need to have X number of square feet of drainage area at this location, and and more drainage area at this next location, versus, well, we think we'll put a 18-inch pipe here, and we think we'll put a 30-inch pipe there. And I can take you to places that we're looking at on a design build right now on I-10. It was built 60 years ago. And they just had a whole stockpile of the same size pipes, and they went and put in 2 pipes every 200 yards. Just measure out 2 football fields and put in 2 pipes. And all they did from Wild Horse Pass to the Gila River, just about. Almost all of them are the same thing, because it's a big flat area. Nobody knew how to calculate that drainage any more accurate than saying, well, it's 13 square miles. And we should get this much water. We'll just spread them all out and everything should be okay. We go back today and run HEC-RAS 2D, and we can see that some of the pipes don't even get water. Okay, the terrain looks flat to you and me when we drive around, and after a rainstorm out there, and I've lived in Arizona all my life, but after a rainstorm out there, there's just water standing on the desert, but it's only a couple inches deep. It makes a nice reflection, but in a couple of days, it's going to be soaked in or evaporated, unless you get a big 100-year flood. And I think in 1993, we got quite a bit of water out there, and you could see water running through the pipes. But it's a night and day difference between just going out and taking a group of guys that, maybe that was their summer job, maybe it was, there's some jobs that are old enough to be Job Corps that we still run into stuff like that. Or WPA, which is basically coming up on almost 100 years old. We built a bridge in Oak Creek Canyon that was right at 100 years of age when we took the deck of it off and rebuilt it. And we found some inconsistencies there that I had to go in and work on with the design to fix it. It wasn't what ADOT quite thought it was.
Gotcha.
So you see a lot of history too. And if you know the history on how things used to be built, that can help you too. AI may or may not know some of those things. So it's got you can get a computer to get all the resources and all the different versions of stuff, but sometimes you have to research a little bit more. Otherwise, you're just repeating the same mistake. So we'll see how it works out south of town here, but we're probably going to have to fix some of those drainages a little bit, tweak them. And some of the pipes, like I say, we don't even have to put them back in. You look at the profile and it looks flat, but it's not. Water can't even get to that pipe.
Gotcha. So, I mean, not to oversimplify everything, but I guess a point that was kind of hit was these applications can do all of these calculations. They can get us all this data, but it comes to a point where we need to go out there and kick some dirt and actually understand the project so we can use applications efficiently and not over engineer something, or going value, we can value engineer it, or so I guess I guess that's what you're kind of getting at. I mean, tell me if I'm wrong. We just kind of need to live it. Oh, go ahead.
Even to understand what the computer is telling you. Sometimes we've seen stuff in the survey applications where it tells you, oh, it's over here. And it's like, yeah, somebody must have reversed a coordinate, because that's not what you're still having to communicate with that software. You're still having to communicate with that computer or that survey instrument, or know how the input goes into the terrain model to make sure that what you're putting in is consistent with what the computer has a frame of reference. And if you don't enter X in the X column and Y in the Y column and Z in the Z column, pretty soon you just got a pile of garbage. So we have to learn how to communicate with it, because it doesn't care, and it might eventually come to a point where AI can figure out, no, your answer can't be correct. Let me give you an example. Like you make a payment on one of your bills, and if you pay, say you paid half a bill on your credit union thing, and you say, I want to pay $100, and then you decide, no, I want to pay some more on. And if you go in to the credit union, at least my credit union, and you make another $100 payment before the due date, and it will tell you, it detects a duplicate payment.
Oh yeah, I get the same ones with like sending Zelle money.
So those are
Okay.
subroutines in there that assume, is the human that's talking to me making a mistake? And so it at least asks you and gives you a chance to think about it. So that's probably the next thing we're going to see in a lot of our engineering stuff and in our survey stuff. Did you mean to turn a right angle again? Like you're setting up 3 points and it's exactly the same angle right down to the second. And so it might seem like a pain in the ass, and there's always an option at the bottom, don't show this message again, those kind of things.
Yeah.
Those are all things that they build in there so that the less chance of a mistake communicating with the machine.
No, yeah, I actually really like that example because that actually cleared it up. And then for our audience or professor, I mean, if he didn't know, I mean, that was the perfect explanation right there. So, but yeah, you kind of hit everything plus more.
Good.
I feel like you answered multiple wildcard questions, so that's awesome.
Okay, good.
But
well,
yeah,
good luck on your project, and let me know if there's anything else you need.
Yeah, well, thank you, Greg, for your time. We appreciate it.
All right.
And you have a good one.
Yeah, you too. Dusty, nice to meet you.
Nice to meet you, Greg.
All right. See you guys.
See ya.
Bye-bye.
All right, bye.
Dusty, you want to hang out with me in here for a sec?
Yeah.
Okay, so that's interview 1. We're good on that. I'm gonna go ahead and stop recording.